Hi, this is Paul Desmond. I'm in the Schneider Electric booth at the AFCOM Data Center World Conference here in Orlando. And I've caught up with Joe Capes, who is the Business Development Director for Cooling for the Americas for Schneider. Welcome, Joe.
Thanks, Paul.
So I just caught the little presentation that you did here in the booth about economizer modes of cooling operation, and I had a few questions for you on that. You mentioned there were 3 factors to consider with respect to economizer. Can you tell us what those are?
Sure. So one of the considerations is obviously geographical location. So what we're talking about here is what are the ambient conditions outside the data center. Obviously preferable to have conditions which are cooler and drier to an extent, because that allows us to leverage the maximum number of hours for free cooling. Another is going to be your supply air temperature. So what's the set point that you're actually operating at? What we want to do is we want to elevate those supply air temperatures to a level that is preferably at the higher end of the ASHRAE recommended guidelines, which tops out at 81 degrees Fahrenheit. So a lot of data centers today operating still at like 70 degrees. Meat locker. Really want to elevate those temperatures so that we can increase our return air temperature as well. And then the third thing is really separating the cold aisle and the hot aisle. You want to mitigate any mixing of supply and return air. But again, you want to achieve the highest possible return air temperature. Getting a return air temperature back to the coil phase, so the heat exchanger at an elevated level, makes the cooling system more efficient, but it also increases the overall capacity of the system.
Okay. You also mentioned a stat that I found kind of astounding. You said a typical data center runs at only 28% of its potential IT load. What are some of the considerations that raises?
Well, I mean, the reality is, if you look at a co-location facility, on the ribbon cutting day, rarely do you see a co-location facility that's already 100% populated. Oftentimes, they're trying to get that first anchor tenant. So if you look at an enterprise facility, typically we see about 28% as the average IT load. And when you're using distributed cooling systems with smaller fans, that can tend to lead to some inefficiencies as compared to using a larger air handling unit. So when you look at an economizer approach, whether it's outside air or indirect evaporative, having those larger capacity fans that are variable speed does allow you to squeeze a couple of extra % of efficiency in reduction of fan power.
Okay. And you also mentioned, economizer mode's been around for a while now, and for a long time it was sort of a secondary mode of operation. People would use it when they could, but now it's becoming more of a primary means. Why is that?
I think in general, if you look at the last decade, we've seen energy prices increase, and lately now we're also starting to see water use efficiency, not just PUE but WUE be another key buzzword in the industry. Water is getting more expensive, energy is getting more expensive, and what I've seen in the industry in the last 10 years is that efficiency and finance, the financial side, is inextricably linked. There's no pulling it apart anymore. So from a design basis, I think all companies are looking at trying to maximize the efficiency of their mechanical plant on day one, not just looking at it as a afterthought or a retrofit opportunity, but it's something that they want to see as part of the day one operation of the data center.
Mm-hmm. It seems like economizer mode's also being used in places where maybe people didn't think it could be used before. You mentioned that you've identified 15 modes of economizers, and that 6 of them were suitable for warmer climates. Can you talk about the properties of those 6?
Sure. Well, operating in warmer climates means that we have to do something a little bit more extraordinary than, for instance, just bringing outside air into the facility. So what we're doing there in most cases is considering maybe an evaporative mode of cooling. Not unlike the feeling of getting out of the ocean on a 95-degree day, but you're shivering because of the evaporative heat rejection off your body. It's much the same that we can leverage in a data center design, where you do have those elevated outside air temperatures, but by using an evaporative mode or an evaporative assist, that allows us to extend the range of temperature outside the facility to still leverage that opportunity for free cooling. In most cases where you do have those elevated temperatures, you are going to need some type of supplemental traditional cooling, whether it be water-based or whether it be refrigerant-based. More often than not, we see companies installing a air-cooled DX direct expansion system as a backup or a supplemental approach to the primary free cooling.
That makes a lot of sense. Well, Joe, I'll let you get back to the event, but thanks for spending a couple minutes here with us.
Thanks, Paul. Appreciate it.